And then the next one comes along and it's going to be bound to it because this next set of information in the sequence says this is what we need, right? And then apparently we have the exact same amino acid coming up next, right? Just because this sequence of 3 and then this sequence of 3, that amino acid is going to be synthesized based on being coded for it. Okay, do we see it?
Yes.
See it? Okay. So based on every 3 nucleotides in the sequence of RNA, you're going to have an amino acid that responds or comes to and is synthesized, is linked together as a result.
Oh.
Yes?
So why is it a circle? Like, why did you move it into a circle?
Because, so we know what the structure of an amino acid is, right? It has a functional group, but then it's, your amino group, your carbon base, and then your carboxyl group, right? We already know that, so we can we can simplify and we can depict it this way. That's all, okay? All right, so there's like a very brief, basic protein synthesis. That's how it happens, all right? Okay, even more specific than saying that that a nucleic acid is a polymer, we can also call it a polynucleotide, right? Polynucleotide. And what that's referring to is we said that each one of these is a nucleotide. We have several nucleotides in sequence. So we say we have many nucleotides. All right? Each polynucleotide is made of monomers called nucleotides. We've already established that. Each nucleotide consists of a nitrogen. All right, so we're gonna draw. We're gonna draw, and I'm gonna actually grab the textbook just so I make sure. But we have a phosphate group. We have a sugar group, and then lastly we have a nitrogenous base. All right, so we're gonna draw all that out. I'm not gonna be as colorful anymore. But let's make sure that we do this correctly. I do want you drawing this in your notes as well. All right. So we have our phosphate group. So that's O bound, E bound, O, double bound oxygen, bound oxygen. We know what a phosphate group is at this point. Okay, we've learned our functional groups, and then we have carbon bound to a 5. I don't like how that looks. It's okay. It's okay. So this is a sugar called ribose. All right. So we have a sugar named ribose, and then this is actually oxygen, and this off of this first carbon we have a nitrogenous base, and I'm just going to symbolize that by putting an N in the middle of it right now. Your nitrogenous base is going to differentiate between different nucleotides, all right? So you have this being the foundation of a nucleotide. However, the particular nucleotide that we're looking at is, and we'll look at structure in a second, but is going to determine what particular nucleotide we're looking at. So we have a phosphate group, right? That's phosphate. And we have a ribose, which is just a sugar. And then a nitrogenous base.
Big words.
Super big words, right? All right. disregarding the phosphate group, okay, we would call this a nucleoside. So a nucleoside plus a phosphate group is a nucleotide. I'm more concerned with, we understand the components of a nucleotide, but you might see it that way later. Don't be thrown off. If you see it, it's the same thing without that phosphate group. So what I drew on the board, all right, was adenine, thymine, guanine, and cytosine. So thymine and cytosine, along with uracil, is a pyrimidine. All right, so these guys right here are called pyrimidines. I believe I spelled that correctly. And then you have these guys, adenine and guanine, that are purines. Those are just names, okay? They're different in their structure. Adenine and guanine are 6 carbon rings with a 5-membered ring attached to it, all right? And then thymine and cytosine are pyrimidines, so it's just a single 6-membered ring. Now, one thing that we want to make sure that we know is that when we go from DNA to RNA, all right, our thymine is switched out for a uracil. So uracil is still a pyrimidine, but we're only going to find uracil in RNA, and we're only going to find thymine in DNA. So even though you have uracil in your RNA strand, it is still going to code for a complementary adenine. All right, so that part of it doesn't change. It's just the molecule, the nucleotide itself changes in structure of it. To build a polynucleotide, right? Nucleic acid. So when we're talking about the polynucleotide, we're talking about the way in which our phosphate group is going to bond to the carbon group. So, or to a carbon group. So one thing that's really worth notating, there's a lot of things, but if I if I de-ring, okay, I unring, and I just look at a ribose as a sugar,
Oh, it's just one of those.
all right, if I look at, I have 1, 2, 3, 4, 5 carbons in my chain right now, all right? If I when I go from this format right here, this ribose, to this ribose right here, okay? This oxygen this carbon, is coming around, bonding to this oxygen. All right, so that's what we have when we're looking at this sugar molecule here. But before we see it in its cyclic form or as a ring, we can number it and we say, so this is carbon 1, 2, 3, 4, 5. And that tells us, all right, then this is carbon 1, 2, 3, 4, 5. All right, so those are the 5 carbons of our carbon ring, but there's just that now as a ring. So that would be its if we're looking at it the length of it versus as a ring. So what we see is that once we've named our carbon, right, this is the 5th carbon, it has a phosphate group attached, right? Just like this 5th carbon, okay, has our phosphate group attached. Awesome, great, wonderful. So then, if I look at where, So the structures that are going to bond together as the polynucleotide backbone, okay? So just for this to link here, so understand that yes, I'm going to have bonds that come together this way, but I also need bonds that come together this way along my chain, okay? So it's going to alternate phosphate group to carbon ring to phosphate group to carbon ring to phosphate group to carbon ring to phosphate group, and it's going to attach to the 5th carbon phosphate group. The next phosphate group is going to attach to the sugar molecule at the 3rd carbon. 5th carbon to 3rd carbon, 5th carbon to 3rd carbon. When it's oriented like that, we say that this end is the 5' end, and this end is the 3' end, indicating that the 5th carbon of our ring is at the top, right? And then the 3rd carbon of our ring is facing the bottom. That's all that it's referring to. Okay? Now, when we are in a strand, when we're double-stranded, those alternate. All right? So, instead of having the 5' end on top for the 1, make sure I follow my sequence around to the bottom. Okay? Our second strand, we say that it's anti-parallel, and the 3' end is at the top, and the 5' end is at the bottom. So it's just how it orients itself with regard to each other. Okay, so they flip, and then they come together, and they sequence. Okay, we feel decent about that? Yeah, that's pretty. I think it's simple enough. Yeah, it's a lot to process.
Yeah.
We see how we numbered carbon here, right? So this right here, let's say here's my nucleotide. It looks awesome, right? When I'm going to bond to my next nucleotide, not across from it, not what it codes for, but just because there's a sequence and they have to be linked together, right? Everything's linked together. It's going to link at this site here through a phosphate group. So it's going to link 5 to 3, 5 to 3, 5 to 3 through our phosphate group. So here, on this carbon, we would have, I'm just going to draw it here, we would have another phosphate group. And then that is going to be attached just like this to our next nucleic acid's 5th carbon. And then you have your ring. And then you have your nitrogenous base. So it's linked to carbons 5 to 4, or 5 to 4, 5 to 3, 5 to 3, 5 to 3. Or it's flipped upside down and it's 3 to 5, 3 to 5. Yes?
Can I move away from this kid, please? Kindly.
We'll say linearly or through our phosphate and sugar components of our nucleotide, excuse me. That is how we arrive at the foundation of a strand, okay? But for DNA to come together across is through the nitrogenous bases. So through adenine pairing with thymine, and then guanine pairing with cytosine, and that happens through hydrogen bonds. That happens through hydrogen bonds. We will watch a video that shows, I'm not going to take the time to draw it when it's already been drawn, but it's talking about the molecular level of DNA and how you can see that the electronegative, it really has so much to do with, right, the electronegativity of nitrogen and oxygen that are a part of these nitrogenous bases that allow it to come together in the correct sequence and therefore form bonds. Yes, Alex?
Take video notes.
Do you have to take video notes? No.
Per K?
Yes.
Can I make a phone call really quick? To my mother? Like, I promise it's to my mom.
Yeah, that's fine.
Okay, cool.